Hi. In this problem, we are going to look at a question involving differential equations and also some series summations. So there are multiple concepts in this problem. You should pay attention and try to solve it first yourself. If you're stuck, then look at the solution. So let fx be a differentiable function such that f dash x plus f of x is equal to 4x e power minus x sine 2x. This is the differential equation that is given, and f of 0 is equal to 0 if limit of n tends to infinity, summation k goes from 1 to n, f of k pi is equal to minus p pi e power pi divided by e power pi minus 1 whole square. We have to find the value of p. So obviously, the only way we can find this summation is if we can figure out what our f of x is. This is a pretty easy differential equation to solve. It is in the standard linear differential equation form. F dash x plus f of x is equal to 4x e power minus x sine 2x. So notice that all we have to do is use an integrating factor. Integrating factor would be the integral of 1 dx, e power integral 1 dx. So integrating factor will be e power x. So multiplying both sides by integrating factor, we get something like this. E power x f of x is equal to 4x e power minus x sine 2x into e power x, right? And e power x and e power minus x will cancel on the right hand side. And here you will get d by dx of e power x f of x is coming out to be 4x sine 2x. And from this, we can say e power x f of x will be the integral of 4x sine 2x, right? Now, obviously, the integral of 4x sine 2x will have to be done by integration by parts. So let's do that. We have e power x f of x is equal to integral of 4x sine 2x dx. By integration by parts, we will take this as the second function and 4x as the first function. We will get 4 sine 2x integral. 4x is the first function, so that will be unchanged. And integral of sine 2x will be minus cos 2x by 2. Then you have to subtract and then differentiate the first function. So 4 and minus cos 2x by 2 is here, dx. So this will become basically minus 2x cos 2x and plus 2 sine 2x by 2 plus some constant. We are getting sine 2x minus 2x cos 2x plus c is equal to ex f of x, right? This is what we are getting so far. Now, obviously, f of x is coming out to be e power minus x into sine 2x minus 2x cos 2x plus c. And because the question has given us f of 0 is 0, you can put x is equal to 0 here. You get 0 is equal to 1, 0 minus 0 plus c, which implies c is also 0, right? So we get our full function. F of x is coming as e power minus x sine 2x minus 2x cos 2x, right? And now we have to go about and try to do the summation that was required, right? So this is my f of x. Let's first find out what is f of k pi. F of k pi would be equal to e power minus k pi. Sine 2x will be 0 minus 2 cos 2k pi. 2 cos 2x. So 2k pi. So that will clearly be 1. So you'll get a minus 2 here. So, oh wait, I missed out the fact that it was sine 2x minus 2x cos 2x. Inside it was sine 2x minus 2x cos 2x. my function was this e power minus x. So this was my function. So it will be minus 2k pi cos 2k pi is 1. So what I'm getting is minus 2k pi e power minus k pi. This is equal to f of k pi, right? And now what we have to do is the summation and the limit. So limit n tends to infinity of summation of k goes from 1 to n and f of k pi, right? So f of k pi is this expression. So we can put a minus 2 pi outside throughout. So we have minus 2 pi and we have limit of n tends to infinity. Summation of k goes from 1 to n. And you will have k times e power minus k pi, right? This is what we have here. So before we can do the limit, we will have to figure out what is the summation here, the general expression for this summation. And if you are familiar with sequence and series chapter, you will realize that this will become a arithmetic geometrical progression. It is an AGP because when k is 1, you'll get terms like this: 1 into e power minus pi plus 2 into e power minus 2 pi plus 3 into e power minus 3 pi and so on till n into e power minus n pi, right? So you can see that the sequence 1, 2, 3 is in AP, whereas the sequence e power minus pi, e power minus 2 pi and all is a GP, right? So the terms here are a combination of an AP and a GP, right? So we'll use the general method for solving the AGP. So we'll say let S be equal to 1 into e power minus pi plus 2 into e power minus 2 pi and so on till n into e power minus n pi. Multiply this by the common ratio, which is e power minus pi into s, and shift it by one step. So you'll get something like this. And you'll get n minus 1 e power minus n pi plus n into e power minus n plus 1 pi. And then subtract these two situations here. And what we end up getting is s into 1 minus e power minus pi is equal to, you will get this sequence, e power minus pi plus e power minus 2 pi and so on till e power minus n pi, and then subtraction of n e power minus n plus 1 pi. So this is the standard technique by which you solve an AGP or find the sum of an AGP, right? So we are getting this expression. We have to solve for s here. And if you do that, you will get an expression like this. S will be equal to, so what is the summation of our GP? The first term was e power minus pi. There were n terms there. So 1 minus e power minus n pi divided by the common ratio 1 minus e power minus pi. But remember that there was a 1 minus e power minus pi here also. So later we'll divide it by this. And then the second term was minus n e power minus n plus 1 pi. So your s is becoming e power minus pi, 1 minus e power minus n pi by 1 minus e power minus pi whole square minus n e power minus n plus 1 pi divided by 1 minus e power minus pi, right? So this is my expression for s. What I have to do is take limit n tends to infinity of this s, right? So you should realize that e power minus n pi as limit n tends to infinity will tend to 0, right? So this part tends to 1. So you have limit of s as n tends to infinity. Also, this part tends to 0 even if n is large. You should also understand that n e power minus n plus 1 pi as n tends to infinity will also tend to 0 because it is n by e power n plus 1 pi. And you can see the top part is an algebraic function, a linear increasing function, and the denominator is an exponentially increasing function. Always exponential functions will grow faster than the linear functions. So as n increases, this thing will tend to 0 because the denominator will become much larger than the numerator. So the second term anyway vanishes and the first term becomes e power minus pi into 1 by 1 minus e power minus pi whole square, right? So that is coming here. And remember, we had a minus 2 pi attached in front, right? So what we get here is minus 2 pi e power minus pi by 1 minus e power minus pi whole square, right? And that is the required summation that we needed. And therefore, from the problem, we needed to find out the value of p, where the form that was given was minus p pi e power minus pi divided by 1 minus e power minus pi square. So it is clear comparing that the value of p will be equal to 2. And that becomes our solution and our answer. So two parts of the question here. Both the parts are on their own very easy. One is the direct linear differential equation solution using integrating factors that you have done many times. It's obvious. The second part is doing the AGP summation. Just because it has common ratio, which is a little weird, e power minus pi, doesn't mean you should not recognize that it's an GP and find the sum of that GP, right? So being able to recognize the sequence and series concept here is vital, and otherwise the problem is pretty straightforward. So that's it for this one. I'll see you next time in the next video.